So now we are looking at the last technique for separating a liquid-liquid mixture. Most of the time, this liquid-liquid mixture is actually one of a very small sample, okay, and we will be using chromatography to separate them, okay. But based on what characteristic, okay, I will actually give a brief outline of what chromatography setup is like before we go into the details how the different components in the mixture is actually being separated. Okay, so this chromatography technique, right, is actually very versatile. It's able to do quite a few things. Okay, of course, it's a separation technique, so it will be able to help us separate the different component in a sample or a mixture, but it is also able to help us identify the number of substances. Okay, so we'll be able to know, oh, are there 3 substances, 4 substances in our mixture? Okay, it will also be able to help us to identify the identity of the substances in the sample. Okay, not just separate them, but identify them. And if you want to check whether the mixture is pure, you can also use chromatography. Besides using checking its melting and boiling point, whether it's melting and boiling at a fixed temperature, we can also use chromatography to do this. Okay, now the most common chromatography that you will encounter in secondary school is actually paper chromatography, and you should be quite familiar with it as well because you have covered it in Set 1. Okay, so how do we set up a chromatography experiment? Okay, I'm going to bring you through the steps, and then after which, as I bring you through the steps, I will also highlight to you some of the important things to take note when you are conducting a chromatography experiment. Okay, and the reasoning behind it, why we need to take extra care for these steps. Okay, so step 1, we will actually use a pencil, okay, and we will draw a line about 2 cm away from the end of the filter paper, okay, and we'll call this the start line. So you imagine I have a filter paper, so I will actually draw a line, okay, over here, all right, which is about 2 cm away from the end of the paper, and this line is called the start line. Okay, so we actually use a pencil to draw this start line is because um, pencil is made up the pencil itself, right, is actually draw the pencil ink is drawn by um, pencil lead. Okay, and pencil lead is made from graphite, which is carbon. Okay, and it's an element. So during the chromatography experiment, it will actually not get separated, so it will not interfere with the experiment. But if you were to, in contrast, if you were to actually draw the line using pen, the pen ink is a mixture of dyes. So it will actually get separated and then it will interfere with the results of your chromatography experiment. So once this is done, we will then place small spots on the start line for you to investigate. Okay, so you can actually place the number of spots based on the number of substances that you are investigating. So let's say for the current example right now, we have 2 of them. Okay, now, these spots that you have placed on the start line, you must ensure that they are small spots. Okay, the reason is because usually in real life context, when chromatography is carried out, right, the spots will not remain small as they move up the filter paper. Okay, they will start to spread sideways. Okay, so they may actually start to spread sideways like that. So if the spots are too big, okay, then they will start to overlap onto each other and then you will not be able to see your results clearly. Okay, so once this is done, the next step would be, let me just clear, oops. Okay, let me just clear the pencil marking first. The next step would be placing the filter paper into a suitable solvent. It can be water or ethanol, all right? But you should take note that the start line, okay, so you see the start line over here is above the solvent level. Okay, where is the solvent level? Okay, this black dots that you see represents the solvent. So the solvent level is here. So can you see that the start line is actually above the solvent level? Okay, because if your solvent level is higher than the start line, okay, it will cause all these spots on the starting line to actually dissolve. And once it dissolves, there will be no separation of the dyes at all. Okay, so we would not want that to happen. Okay, then after which, as you the moment you place it into the solvent, then gradually the solvent will start to move up the filter paper. And along with it, right, it will bring the components in the mixtures coming from the spots on the start line along with the solvent. Okay, so and then there is a separation that will be happening. Okay, so you're supposed to observe the solvent front carefully as it travels up the paper. Okay, what is a solvent front? Okay, it's actually where the solvent reaches. So usually, right, we will try to ensure that we allow our chromatography to actually continue until, right, the solvent front is actually near the end of the paper. Okay, we try not to stop halfway. Okay, this is not a very good chromatography experiment, because if the solvent front is near the end of the paper, then you will have a complete separation of the dyes or the spots. Okay, but if they are all clustered very closely together, because you only allow the solvent front to travel half or less than half of the filter paper, then you're not allowing them sufficient space for separation. Okay, and finally, you'll notice that during chromatography, we may want to cover the chromatography experiment with a lid. Okay, this is to ensure that the solvent that is traveling up the filter paper from is to ensure that it does not evaporate so quickly. Okay, so we want to prevent it from evaporating quickly. Otherwise, if it were to evaporate very quickly and you are only midway through the chromatography experiment, then you will not get accurate results as well. Okay, so these 4 steps that I've written is good for you to be able to know how to describe and draw, okay, the setup as well. You do not need to draw this setup. You can actually just learn to draw the one that is in the notes on page 20. Okay, so here we are going to take a look at some possible results. Okay, so usually after doing the chromatography experiment, you will get a filter paper that looks something like this. We assume right now, right, what I'm trying to investigate is actually this black ink or black dye over here, and I'm suspecting there could be red, blue, green, or orange that is in the black dye. Okay, so based on this chromatogram, we are going to have a deeper discussion about what we can understand from it. Okay, this final piece of filter paper is called a chromatogram. Okay, so how does chromatography works? Okay, chromatography works based on the difference in solubilities of the different component in the mixture in a certain solvent. Okay, so if the solvent you're using is water, not all substances is as soluble as each other in water. Okay, so because of that, they will travel a different distance from the start line. Okay, so we are going to understand that. Okay, before I talk about the relative solubility, right, I just want to pinpoint something to you. Okay, earlier on we said that chromatography serves 3 purposes. It's able to separate the components in a mixture. So you can see black is clearly a mixture, and chromatography has helped us to separate the components in there. And while separating, you're able to identify the number of substances in the mixture. Okay, and if you look at this black ink over here, there's a total of 4 spots that is appearing. Okay, so it tells us that this black ink is made up of 4 different substances. Okay, so you realize we are able to identify the number. Okay, and still on the same point, you will realize the red, blue, green, and orange, all of them gave us only one spot. Okay, this clearly implies that all of them are made up of only one substance. They are all pure. So it helps us to not just identify the number of substances, and if the number of substances is 1, then it will tell us that your sample is pure. Okay, that's the third use of chromatography. Okay, the last one, which we'll be elaborating in length, is also going to be able to help us to identify what could be the substances in your mixture. Okay, so let me just remove my pen marking first. How does it work? First and foremost, you will realize that if I were to box up these 2 red spots, the green and the blue, okay, it's not so much of the color, but if you take a good look, you will realize both the red spots, right, actually travel the same distance from the start line. Now, if the 2 spots travel the same distance from the start line in the same solvent, it is actually giving you a big clue that the 2 spots are the same. Okay, so likewise, the green and this green, right, is also the same. The blue and the blue is also the same. Okay, clearly we cannot see any orange spot over here, so it tells you that there is no orange, okay, in the black ink. Okay, and there is an unknown purple dye over here, which does not coincide with any of the suspected 4 dyes. So it will be your job to go and find out what could be this purple. Okay, this is what we can interpret from the chromatogram itself. Okay, and now we would like to actually go into detail. Why is it that some dyes travel a shorter distance, but some dyes travel a longer distance from the start line? Okay, so let me clear the pen marking first. Now, this particular dye over here, the blue, if we were to compare it with the red, you'll realize the blue travel a much longer distance. The reason is because this blue dye is very, very soluble in the solvent. Okay, if I were to draw the solvent front, right, it's somewhere here. Okay, so if I were to draw the solvent front, it's here. So you'll realize actually the distance in which the blue dye traveled, right, is very much very close to the distance that the solvent has actually traveled. And that happens because this blue dye mixes with the solvent very well. So in a way, they get stuck to each other very well. Okay, it's only until the later part of the as it moves up the filter paper, then the blue dye eventually gets dropped off onto the filter paper. The red dye, in contrast, travels a very short distance. So it implies that the red dye is actually not that soluble in the solvent. So it gets so-called like drop off very quickly. Okay, drop off with the inverted comma very quickly. So this exhibits to you that chromatography works on the fact that different substances dissolve differently. Okay, they have different solubility in the same solvent. Okay, if you were to change the solvent from maybe water to ethanol, you might not get the same chromatogram because the same substance might be more soluble in ethanol now and not so soluble in water. So that's why the positioning of the spots will actually change when you um, use different solvent. Okay, finally, we also discussed this part already. If the dyes are identical, then they will definitely travel the same distance. So using this concept, you can actually identify the substances in the sample itself. Okay, now an extra moving forward, right, there are some extra concepts that you'll be learning in Sec 3 as compared to when you're in Sec 1. there's actually a more sophisticated way of finding out the identity of substances in your mixture. You do not need to, add spots of all the suspected substances all the time. Okay, we can actually make use of this idea of RF value, which is known as retention factor, to help us identify our substance. Okay, so first we must understand what is RF value. Okay, RF value is actually a calculated ratio, okay, based on the distance traveled by the spot. Okay, I call it X over here. Then divided by the distance traveled by the solvent, which is from the start line to the solvent front. Okay, which is Y over here. So if you were to take X divided by Y, okay, you will be able to get a value. Okay, this value it has to be less than 1 because you cannot have a dye that travels further away, further than the solvent front. So all these RF values are usually less than 1. Now with this RF value, right, you can actually look at a data book, compare it with a data book with a lot of known RF values, okay, that has already been compiled, and you will be able to draw a similarity and conclusion about the identity of the unknown in your mixture. Okay, so the RF value is also very versatile because it doesn't require you to have a standard length of your filter paper. Okay, here in this diagram, right, you can see that I actually have the first experiment whereby the solvent front is only 4.5 cm, but the second experiment I actually allow the solvent front to reach a longer distance. Okay, we still have the same substance that is being separated, and it is discovered that when you eventually calculate the RF value of the same substance in the same solvent, but allowing the solvent front to travel a different distance, or you can also say using different length of filter paper. Okay, therefore in the end the solvent front will travel a different distance. The RF value turns out to be the same. So therefore it doesn't matter. Okay, it doesn't matter how long your filter paper is or how far the solvent front has actually traveled. The R value will be indicative to tell us the identity of the substance. Okay, so uses of R value, I've already mentioned it. So you can actually identify substances without having to spot so many suspected substances. Okay, that there is no end to this. Therefore, you just need to work out using one spot and then calculate the R value, and you'll be able to identify it very quickly. All right. Besides the usual paper chromatography where the solvent is always rising, okay, we call it ascending paper chromatography. Paper chromatography can also be carried out where the solvent is at the top. Okay, then you run the filter paper down. Okay, this is called descending paper chromatography. So for descending paper chromatography, actually it works exactly the same way. The only difference is, right, because the solvent is actually moving down, it does not need to work against gravity. Therefore, you find that it is possible for you to actually use longer sheets of filter paper and allow the different spots to get separated, okay, over a larger distance. Okay, so you can have a wider separation between the spots. Okay. Uh, Chromatography is normally performed on dyes, pigments, and even proteins. Okay, and very often, right, these spots that you get after chromatography, they may not appear colored to you in your eyes. Okay, so they could be colorless. They have already been separated, but they appear colorless. So you actually cannot see these spots at all. It doesn't mean that the experiment has failed. All you need to do is to actually make use of something called a locating agent. Okay, so this locating agent, right? If you were to spray on the filter paper, the locating agent will react with the colorless substances on the filter paper to form a colored product, making it visible. Okay, so you need to know what a locating agent does. Okay, let's put a triple star on that. Do not just blanket and give a very a very a very non-scientific answer like locating agent help us to locate the spot. Okay, you have to tell me how does it do it. Okay, so that is about locating agent. Okay, finally, some applications of chromatography. Actually, we use chromatography very often in recent years as well. COVID-19 test kits are all based on this concept. Okay, even pregnancy tests. Okay, but chromatography, right, is very widely used in helping us to detect any possible harmful pesticides or harmful substances in our food. Okay, there have been many cases where NEA has withdrawn certain food, okay, from supermarket because they discovered prohibited substances, okay, in the food itself. All right, and all these are actually detected through chromatography. Okay, another popular one would be detecting drugs that athlete has taken. Okay, so usually when athletes go for competition, okay, urine samples will be taken from them and it will be tested. So if the urine samples show up spots that coincide with those banned drugs, okay, to increase usually the performance of the athlete, then the athlete will actually will actually be banned or has his medal removed or revoked, and then actions will be taken. Okay, so that's also another use of an application of chromatography. Okay, so these are some the on the last page, right? These are actually some chromatography questions which I already answered previously. So it's just for you to actually jot down the answer. You can pause the video to take down the answer, okay? And then you continue on when it's done. Okay, so with that being said, we have completed all the separation technique, filtration, separating funnel, chromatography for liquid-liquid mixture. Liquid-liquid mixtures which are miscible, that means they are soluble with in each other, but they must have different boiling point. We use fractional distillation to separate them. The liquid with the lower boiling point distill first. Okay, but if the liquids are immiscible, our job will be easier. Okay, these liquids, right, they will be separated based on their difference in densities using a separating funnel. Okay, so and the last liquid mixture, we can use chromatography to separate them because they have different solubilities in the same solvent. So the spot that travels a longer distance from the start line is the one that is more soluble. Okay, so with that said, actually we have completed all the learning objectives for the chapter. Okay, it's a very long chapter, but it's good to have a clear understanding of everything. We have covered all these. Okay, together with magnetic attraction and even sieving. And we have seen how solid liquid and liquid mixtures can be separated. We talk about RF value. Okay, we learn to how interpret paper chromatography or paper chromatograms. And we also talk about the need for locating agents to identify colorless compounds or substances obtained from the separation via paper chromatography. Okay, so the last thing to do is to complete page 25 and 26 of the notes. Okay, there are quite a number of MCQs that I have prepared for you. So it's alright, you can take some time to test yourself out, and then we will discuss the questions in class.